And now let's have a look at what are the components of a reinforcement learning agent. A typical reinforcement learning agent may have one or more of these three components. First one is the policy. So policy is uh, either deterministic or stochastic. So the idea is the policy tells the agent what it has to do, or what are the possible things that the agent can do given that it is in a particular state. The agent will pick any one of the possible actions and then it will follow that and go to the next state. That is why we say that the policy can be deterministic. For example, say if I have my Mario game, I want to make the Mario move. So at any given instant of time, I may decide a deterministic policy which says go up or down or go straight ahead or go back. So this is a set of policies that I can give to that particular agent at a particular state. On the other hand, we have the situation where it may require a stochastic policy. That means no such predefined actions may be possible. For example, maybe a robot is trying to learn to drive on its own. In that case, there are infinite possible steering angles that the robot can take, maybe to avoid an obstacle, maybe to reverse. So there are several possible states, and you may have a stochastic policy which you may have to deal with in that particular case. So the second component of a reinforcement learning agent is a value function. So this value function is the function which tells the agent how good the current state or the current action is. So it's basically like giving encouragement for or discouragement to an agent for being in that particular state or for taking that particular action. So if you have a look at this equation, the expectation of or the value of a particular state, you can see here the value of a particular state is the expected value of the reward at the next state and the discounted rewards for what it is going to get in the future if it is currently at the state st. So the value that is assigned for the state at time instant t when it is in that state s is the reward that it will get in the next time instant and all the rewards it is going to get in the future. So this is the idea behind value at a particular state. And you can see there is a discount factor which is usually uh, less than 1. It's a 0 comma 1, not 0.1. So you will have a reward factor which is less than 1. For example, if you put the discount factor as 0, so if you put reward factor as 0, none of the future rewards will matter to the agent because everything else will go to 0. So the idea is if you make discount factor as 0, the value of that particular state is only dependent upon the reward that it is going to get at the next instant. On the other hand, if you give the discount factor as 1, it it basically means that the value at that particular state is dependent upon all the future rewards that it is going to get. So it becomes extremely dependent upon all the future actions that the agent is going to take. But typically the value will be between 0 and 1 so that the rewards that it is expecting in very long future is not mattering too much at the right time when it is trying to maximize rewards in the next few time steps. So this is how discounting typically works. That's what is being done here also. The third component that is usually present or not present depending upon the type of agent that you may have is the model. So model is kind of uh, a predictive system which is going to say what the environment will be doing in the next step. So you can see the this is typically the agent's representation of the environment, as we said. You may We have already discussed cases where the environment is not fully observable. In those cases, the agent will have to come up with an internal representation of what the environment could be and then take actions accordingly. Because agent cannot be completely unaware of the environments. If it cannot see the full environment by itself, it has to create an internal representation of what it feels the environment is like. So that is what the model does. So you can see the uh, model or the behavior of the model is such that there is a, transition function p which predicts the next state. That is, you have the current state, you have the next state as s dash, so which is a function of the current state and the current action that is being done now. So this is again a stochastic or probability distribution based model. And similarly, you have a model which generates the reward function as well, which will estimate what the reward is going to be at the next instant when you are at current state S and you are going to perform an action A. So this helps the agent come up with an understanding of what is the likely payoff if I do a particular action. So this makes the learning process a little bit better for the agent because he gets an understanding of what are the likely rewards and the risks of performing a particular action. And the next important thing that we have to see is what are the categories of reinforcement learning agents. There are five broad categories of reinforcement learning agents. The first one is the value based agent. So what value based agent does is it will tell the agent exactly how good each action is in a particular state, and the agent will have to pick the best one among them. So we will see one example. The second type of agent is a policy based agent. So in case of a policy based agent, you only have uh, certain representations of the policy. That is, you tell the agent what it can and cannot do at every state. Based on that, it will just pick the one which will result in the maximum payoff or the maximum rewards, and then it will proceed in that particular direction. As an example, let's take this case. The aim is that the agent should start from the start point and it should reach the goal point in the shortest possible number of steps. So reward that you get is -1 per time step, and the actions that it can take is it can either proceed north, east, south, or west, and the states are the agent's current location. So you should be able to reach the goal with the shortest number of steps, because more the number of steps you take, the more negative your rewards become. So the best possible scenario is to minimize the number of negative rewards. And that can be done only when you reach the goal in the shortest possible number of steps, because each step requires one time instant. So if we are using a policy type agent, you will know that the ideal policy is from here you go this way, and from here you go this way, and you keep on going like this, like this, like this, like this, like this, like this, and like this. So the optimal policy is given to go in this direction, and for each cell there is one policy that is provided. But this is the optimal policy that the agent has to follow. If you remember in the problem statement that was given to us, the agent could go east, west, north, or south. Any four directions it could go. But here, if you take the second cell, you can see it has possibility of only going in three directions. It can go back, it can go, I mean, like it can go to the east, it can go to the north, it can go to the south, but it cannot go to the I'm sorry, this is the east, I think. So it can go to the west, it cannot go to the east. So it can go only in three directions. So you will have only limited number of actions it can take. So that is the idea of policy. And if you're looking at value, just have a look at this. So if the agent is starting from the start point, the reward or the value is minus 16, it has to go to the next step. There is no other option. So it goes to this step. You get the value of minus 15. Now the agent can go in two directions or three directions. It can go back where the value will again increase to minus 16. It can go down where the value will again increase to minus 16, or it can go to the top where the value will decrease to minus 14. So this is the best solution. Agent will jump from here to here, and then it will go here because the values are decreasing, and once it reaches here, it again has got three options: go here, go here, or go here. So it will just check the values or the value functions at each of these three cells. It finds that the lowest value is at this point, so it will jump here, and it keeps on going all the way here till it reaches the goal. And at the last cell, if you see, the reward is the highest because it is the least lowest value in the entire set of cells. So this is how a value function based approach to training an agent will work like. So there are other three categories of agents also. Actor critic agent, where you have um, a value based and a policy based agent. So you will have um, an actor and a critic which says how the agent is particularly behaving. Actor is the one which is the agent which is actually doing the action, and the critic is the uh, say, let's will not call it supervisor, is let's call him a critic who says how good your actions have been. So that is the actor critic type agent. And the fourth category we have already seen is a model based agent, where you create a model of how the environment is kind of behaving and then try to get the best possible behavior. And then you have the last category, which is the model free agent. And this is where the model free type agent behavior kind of resides. And it will try to automatically figure out a policy to get the best possible rewards. So these are the five broad categories of reinforcement learning agents. We will try to see some of them in the next few uh, lectures, and we'll also try to do a few examples in MATLAB on how to train an agent and how to make it behave the way you want to. So we'll see that in the next few classes. And in the meantime, I will recommend going through these references. The presentation also has got a few slides from these sources. David Silver's lectures are very relevant and very useful. I suggest that you have a look at that. A lot of that is available in YouTube and also as presentations and PDF files. Many of the references I had to go through to learn about reinforcement learning relied on David Silver's lectures. So this is a very good starting point if you want to learn reinforcement learning. So we will continue with reinforcement learning in the next videos. So please stay tuned till then. Goodbye.